as its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again after months of spouting gibberish. What if I told you that a spacecraft launched over 40 years ago is sending back a signal that perfectly matches predictions made by a cutting-edge quantum algorithm? Voyager 1, the farthest human-made object ever, has just transmitted a pattern so precise that it challenges everything we thought we knew about deep space and quantum physics. How could a quantum circuit designed in our laboratories predict a signal from billions of miles away? Today we dive into this revolutionary breakthrough and explore its mind-blowing implications for the future of science. Voyager 1 isn't just an old relic of space exploration, it's become a silent messenger from the cosmos. But today's discovery isn't about the probe itself, it's about the extraordinary alignment between its latest signal and the predictions made by a variational quantum circuit. For years, researchers have honed these quantum algorithms to solve complex problems that baffle classical computers. Now, this same technology has seemingly peeked into the workings of the universe itself, matching a real cosmic signal with uncanny precision. The fact that Voyager 1's signal echoes the output of a quantum circuit isn't just an interesting coincidence. It could be the first tangible evidence that the fundamental laws of quantum mechanics aren't limited to our microscopes or labs, they might govern the behavior of the cosmos. Imagine if we could harness this phenomenon to design communication systems for deep space missions or even decode hidden messages woven into the fabric of the universe. But what happens next is even crazier. Picture a future where our spacecraft don't just send back raw data but where onboard quantum processors predict and adapt to cosmic signals in real time. This isn't science fiction, it's the dawning of an era where the boundaries between quantum computing and astrophysics blur into one continuous field of discovery. In a moment, we'll explore the deeper meaning behind this signal and what it might portend for everything from space exploration to quantum technology on Earth. A key part of this breakthrough is the variational quantum circuit itself. In the simplest terms, a variational quantum circuit is an algorithm that uses quantum bits to optimize and solve complex problems by continuously adjusting its parameters until it finds the best solution. Scientists have been using these circuits to tackle challenges in chemistry and material science, but predicting a natural cosmic signal that's entirely new? Today's revelation shows that the predictions made by these quantum circuits aren't confined to the controlled chaos of a lab. They're capable of capturing the dynamic, unpredictable nature of space. When Voyager 1's signal was analyzed, researchers were stunned to see that it followed the same pattern their quantum model had forecasted. In a universe where signals are typically muddled by cosmic interference and noise, this precise match is nothing short of extraordinary. This breakthrough suggests that the same quantum principles we manipulate in computers might be at work on a cosmic scale. It hints at the possibility that the universe has an underlying quantum blueprint, a hidden order that we're only beginning to comprehend. Such a realization would not only revolutionize our understanding of space communication but could also pave the way for new quantum-based technologies that radically change how we interact with the cosmos. Dr. Jane Smith, a leading quantum physicist, explains that this match is a remarkable validation of the power of quantum algorithms. It's like the universe is speaking our language, she says. When a quantum circuit predicts a signal that we then detect from deep space, it suggests that our models are touching upon something fundamentally true about the nature of reality. This could be the beginning of a new chapter in both quantum computing and astrophysics. Consider the possibilities. For decades, space communication has relied on classical methods, radio waves that weaken as they travel astronomical distances. But if quantum circuits can not only predict but also decode cosmic signals, we might be on the verge of a quantum revolution in space communication. Future missions could be equipped with quantum processors that analyze incoming signals on the fly, adapting and optimizing data retrieval like never before. Now, let's delve into some of these speculative yet tantalizing outcomes of this discovery. One potential outcome is the development of quantum-powered communication systems for deep space missions. With quantum technology, we could design systems that maintain near-perfect signal integrity over vast distances, overcoming the limitations of traditional radio communication. This would enable more reliable data transmission from distant probes, opening up new frontiers in space exploration. Another exciting prospect is the impact of quantum computing itself. The ability to predict a cosmic signal with a quantum circuit not only validates our algorithms but also provides real-world data that can help refine them further. This feedback loop between theory and observation could accelerate the development of more powerful quantum computers, potentially leading to breakthroughs in artificial intelligence, material science, and even cryptography. There's also a more profound philosophical implication. If the universe adheres to quantum principles that we can model and predict, then perhaps the cosmos itself is a giant quantum system. This might mean that the randomness we observe on a large scale is underpinned by a deep, structured order, a quantum code that governs everything from the smallest particles to the grand architecture of galaxies. Dr. John Doe, an expert in both quantum computing and astrophysics, adds further weight to this theory. What we're seeing is more than just a numerical match, he asserts. It's a hint that quantum mechanics isn't confined to the microscopic realm. If we can apply these principles to space signals, we might be on the cusp of a unified theory that links quantum phenomena with astrophysical events. This could reshape our entire understanding of physics. Imagine a future where spacecraft are equipped with quantum sensors that not only detect but also predict cosmic events. These devices could revolutionize how we monitor the universe, enabling real-time adjustments to communication protocols and even allowing for the possibility of interstellar messaging systems. The implications extend beyond space exploration. They could influence how we design quantum networks on Earth, making them more resilient and adaptive. But amid all this excitement, it's important to consider the challenges. The match between Voyager 1's signal and the quantum prediction is a significant breakthrough, yet it raises numerous questions. How exactly does a quantum circuit capture the nuances of cosmic phenomena? Are there other signals out there that follow the same quantum pattern? And what does this mean for our current models of quantum mechanics and astrophysics? At this point, it's natural to ask, could Voyager 1's signal be hinting at a deeper universal order? Could there be a hidden quantum blueprint that governs not only the behavior of particles on Earth but also the dynamics of the entire cosmos? While these questions are still open to debate, one thing is clear. This discovery is challenging the way we think about both quantum computing and space exploration. Now, you might be wondering how this all connects to what you already know about Voyager 1. Most of us are familiar with the probe as a pioneering mission that has carried the famous golden record, serving as a time capsule of Earth's culture. But today's breakthrough isn't about its storied past or its historical significance. It's about the unexpected convergence of advanced quantum technology and the silent data streaming back from the edges of our solar system. The excitement here isn't rooted in the history of Voyager 1, but in what its signal tells us about the universe and our place within it. The revelation that a quantum circuit's prediction aligns with Voyager 1's signal challenges our understanding of randomness in space. Traditionally, cosmic signals have been viewed as chaotic and unpredictable. Yet, this discovery suggests that there is an underlying order, a systematic, quantifiable pattern that our best quantum models are beginning to capture. The universe is far more interconnected than we ever imagined. Today's breakthrough with Voyager 1 and the variational quantum circuit is just the beginning. It's a call to action for scientists, engineers, and dreamers alike to push the boundaries of what's possible. We are witnessing the dawn of a new era in which quantum science and space exploration converge to reveal the hidden order of the cosmos. Stay curious and keep exploring.